All right, I think we are ready to go. Let's make sure the volume is looking pretty good in OBS. Let's get this out of the way. All right. Okay, quick introduction for folks that might be new. My name is Tim. I go by foamyguy online on like GitHub and Discord. In this stream, we'll be working on CircuitPython project. In this case, it's going to be this little sort of Pacman-like game that I'm calling Pie Chart Chomper. So I started this a couple weeks back. Also made the library that goes with this little hardware add-on to the Pico on the stream a couple weeks back. So if folks are seeing this in the future and you're interested in the particular project we're working on, there is a bit of history in the last couple of weeks of streams. I think I skipped it last week and worked on something else, but I think the week or two before that I was working on stuff related to this, so you can check it out there. If you are brand new and you don't know anything about the stream or about what we're working on here, CircuitPython, you can find out a little bit more at circuitpython.org. This is the website for it. It's basically a version of Python that can run on these tiny computers that are called microcontrollers. There's a bunch of them in the backgrounds of these pictures on this page, so you can see, they come in all different shapes and sizes, and we are writing Python code that runs on these little devices and allows you to connect up with, hardware peripherals like lights and buzzers and beepers and, speakers and screens and any kind of sensor you can think of. CircuitPython gives you the ability to write Python code that will interact with all of those things from these little computers. If you want to get involved in the project, you can go to circuitpython.org, and there's a contributing page right here. This is going to list out all of the open pull requests and open issues that are across all the libraries that we use in CircuitPython. So this is a really good way if you're trying to get started and you don't necessarily have a lot of experience, or you want something, on the easier side of things to work on. Lots of times the pull requests and open issues are a good place to start. Especially right now, we have lots of pull requests that are, issues that are for the type information. So that's a good spot to start if you're brand new, because you can usually look up what the types are supposed to be, and some of them don't have a whole lot of changes that need to be made if there's only a couple functions in the particular library. So those are marked as good first issue. You can filter in this drop down here, so check those out if you're interested in getting involved. If you want to support the project, but you don't necessarily want to get involved in the development, another way you can do that is by purchasing hardware from Adafruit. This is their website, adafruit.com. These folks are a hardware and software company based out of New York. They sell a bunch of the little microcontrollers. They sell all kinds of sensors and lights and speakers and all the stuff that you can plug in to do with your microcontrollers. So lots and lots of great toys if you want to, start working on this stuff or start playing with it or use it in a project. You can pick up hardware from here, and since they are the folks that are providing the financial backing for the CircuitPython project, they pay folks to work on the project full time. By purchasing hardware from them, you are, supporting the project indirectly. So definitely always recommend folks to do that. And they have all sorts of guides and other things as well. They pay me to write guides sometimes. They pay me to work on other software. This stream is not a paid endeavor, or, I'm not getting paid to promote it at the top here. I always just like to do that for folks that might be new to the stream and want to get involved, and just to let them know about the support that Adafruit provides. Okay, Dexter, you're working on a brick face. I'm not sure. Is that the little Lego looking microcontroller? Brick face NP. What is that? Let me look that up. Brick face. Oh, I should probably switch this one back, huh? Yeah. Let's do that. Brick face. Okay, it looks like one of them is, you got the NeoPixel grid there. Is that part of what it is? Brick face. Oh, this is not. Maybe if we dead pixel mortar. I get the name right. Brick face. Yeah. Neat. So is that, looks like a feather wing, is that right? Oh, okay. Okay, yeah, it is the NeoPixel feather wing. Oh, okay, is that the name of the game? Is it like oh, what's the name of, I think I mean, I guess maybe there was one called Brickface. I knew of this game as a different name. Brick Breaker, I think. Sometimes I see this game called. Is that you bounce the ball up and down or side to side, and when it hits a light, it will turn the light on or off, one of the two? Breakout. Yeah, that's another game, I think. Nice. Cool. Yeah, that looks like a cool game. What, you just have proto section or something else down there, it looks like? Oh, maybe it's a feather. Looks like probably a feather tripler. And you got like an M4 or something on there to run it. That's pretty cool, man. Thanks for sharing. You always got lots of you always have something interesting going on each week. Feather tripler, nice. Cool. Yeah, this would be fun to port to maybe like Matrix Portal as well would be a good platform for this kind of game. I guess you need some controls though, right? You need buttons to move the platform. There's a couple buttons on it, but I don't know if you could maybe mount it and plug in some extra buttons or something. That'd be kind of cool looking. Okay, this is in Chrome. I'll close this one off for now. And yeah, so I'm gonna be working on the Pacman game that I started a couple weeks back. Basically, we're just gonna kind of keep going on it and see how far we can get today. So let's get the code opened up for it. So we're loading our map from the JSON file just to kind of catch folks up to speed if you didn't see it last time, and honestly just to wrap my head back around where I'm at here. So what we have done so far is it's rendering the map from the JSON file, which we created using Tiled, the tile map editor software. So we created our map, it's getting rendered on the screen. We have our little character, pie chart character. We can move by pushing one of the directions on the D-pad. In fact, we can move all 4 directions by pushing them on the D-pad there. But what we don't have yet is any sort of logic to make him, the pie chart, chomp the little extra pixels. So right now we just kind of run around and don't really interact with anything except for walls. The walls we interact with by, not being allowed to run into them. So that part is actually working all right now. So I think the first 2 things I want to do are make it so when you run past one of the little dots, you'll eat it, because that's how the original game works. And then the other thing I want to do to start off with is when you turn, like if I'm imagining the character moving forward this way and then turning to point upwards, it's allowing you to clip the wall a little bit. So it's a little difficult to explain all the way. I'll see if I can get it to work, but basically, like, I'm a little too close to the wall right now. I'm not actually supposed to be allowed to get that close to the wall. You can see I'm even intersecting it as I move up and down there. I don't have a great way to stop on it, so I can't just like park right there. But what you'll notice is, like, if I come over here and then I go over this way, like, there's always a little bit of space in between me and the wall there. And so basically what's happening is I'm being allowed to turn to point, north or whatever direction, earlier than I get all the way past the wall moving to the right. So basically we're going to the right and we turn before we get all the way past the wall. And that's allowing us to kind of overlap a little bit. Whereas if we go, straight into the wall, straight on, like when I did from all the way over here, without turning, I stop in the proper place. There's a little bit of a gap between me and the wall. So I think the way I want to solve that is when you turn, we will just snap the character into the tile that you're moving into. So if you turn a little bit early, you'll just get snapped a little bit over to the left, and you'll actually be centered on that tile. If you turn a little bit late, like when you would be, in the other column of the two columns here, then you'll get snapped back just a tiny bit to fit centered within that column. So hopefully that makes some sense. Those are going to be the first two things that I work on, and I think I'll work on that snapping to the center first. So let's take a peek code here, just wrap our heads back around how this is working. So we have our driver for the display that we have plugged in, which also handles the keys and things inside of there. We load up our tile map game. Let's see, setting up the display and the group and everything so it will show on the screen. That's pretty straightforward. New lock, this looks like maybe is going to be storing the location where the player is about to move to next, is my guess there. We'll see when we get a little bit deeper in the code. Boolean for whether or not we moved. We start this, we initialize it on the same spot where the character's already at. And I think this is going to be tile coordinates probably, so not pixel coordinates, but tile coordinates, which in this case are, they're 15 by 15 if I recall. Be in the tiles. I guess it's probably pulling it out of the map at this point, maybe. I think those are 15 by 15 tiles though. Okay, so we're going to check the events on the buttons. If a button was pressed, then we will set the direction of the player entity. And that's going to be pretty much it whenever a event gets pressed right now. If it was an arrow key event, so we have a D-pad right now, so if it was an arrow direction, then we just set the direction of the player entity to the direction that was pressed. When it gets released, nothing is really happening. We're just printing, so we don't really have any action right now. When you release, we update a clock counter each time. If the previous tick plus the tick speed is less than now. Okay, so this is all handling the input, and I guess down here this is going to be handling the actual kind of physics of the game. It's going to, make everything go by one tick. So right now, the main things it does is going to be moving the player, I think, is all we have. So if the player is pointed in a direction, pick out the pixel location of the next spot where the player is about to move based on the direction it's facing. Translate that into tile coordinates. Check if we are allowed to move on that tile or not. If we are allowed to move on that tile, then we go ahead and move in that direction, basically. The direction that we were headed, we go ahead and actually take a step 1 pixel in that direction. Else, if we are not allowed to move on that tile, then we set the direction to none, which causes a character to stop moving. And then if the direction is not none, so if we do have an actual direction, then also check if it's time to update the player. So we have a little bit of a limiter, so it doesn't just go as fast as it can. We have a limiter that says, like, the character only moves every X, amount of milliseconds or something. So we're checking that, and if it is time to move, then we do... Oh, no, this is not for moving, actually. This is not for moving. This is for changing the sprite. So this is like, as the little pie chart moves along the world there, sometimes his mouth is open and sometimes his mouth is closed. So it's like, doing the chomping action. And that is actually switching between two different sprites. If we pull up the sprite sheet, we'll be able to see that. So for each direction, we actually have two sprites, one with the mouth open, one with the mouth closed. And so we have, 4 of those, one for each direction. So that's what this bit down here is doing. If it's time to change the sprite, then we go ahead and change the sprite And of course, we update the variable so that we can compare against it next time. So that's what's going on down here. This is all movement. This is all changing the sprite back and forth. Okay, so basically what we want is when we turn, if we're going a different direction than we were before, we want to snap to the new tile. So how do we do that? I think we say, I think we kind of need to know the previous direction, don't we? Because we need to be able to compare to the direction that we used to be going. And if it's different, this is when we want the special behavior. Or do we care? Maybe we could just do this every tick, honestly. Yeah, I guess we don't need to do it specifically when we turn. That's when the sort of bug shows itself, but we could just check every tick. Well, but we need to know the direction we're going. Basically, if we're going up and down, then snap ourselves to the tile that we're in vertically. If we're going left and right, snap ourselves horizontally. Okay. So we need to find the origin point, which I think is upper left corner of the tile that we're about to land on. So I think there might be some helper code for that in game object. Let's see. Where are we getting the game object from? Is it in lib? File map game. Probably rename it to use lowercase. That seems to be the convention for libraries, but so I think we have, let's see. Tile grids. Map object, tile properties, get tile properties, update the player location, update the cursor. We're not using the cursor in this game. Is tile movable? Get tile for tile chords. This returns the tile index. Player entity. Yeah, I guess we don't yet. I think we want a function that you can pass it a tile coordinates, I think, and it will return to you the upper left corner in pixels. Yeah. Def get tile origin. Call this the origin point. I think that's the right concept. So you'll pass in tile chords. We'll have the same thing as this. Okay, so we don't care which layer. I don't care which layer we're on. The coordinates will be the same in all the layers. So essentially, we need to find the smallest multiple of... Well, we need to find the largest multiple of the tile width that is still smaller than... Well, no, actually, this one, I guess, since we have tile coordinates, we just multiply, right? We just multiply tile coordinates times tile width. Yeah. So what do we want to return? Do we want to return a tuple, maybe, I guess? Return tile chords x times, we should have like a tile width, right? Tile width. Okay. Tile chords y times tile, right? Mapping tile coordinates to pixel coordinates. Yes. Yep, 100% right. Yeah, so we're passing in the tile coordinates, and then we're getting back the top left in pixels of that tile. I think it should just be coordinates times tile width. So like if we step through the logic, if we add 0, 0, we would get 0 times tile width is still 0. Ooh. This we don't want. If we had 0 here, we would get 0 as well, which makes sense. If we passed 1, 0, we would have 1 times tile width, which is 15, which is the top left of the second tile, the tile with index 1. Yeah, so I think that's right. So we'll save this. I'm going to head back here, and then we're going to say, let's see, next tile chords. So I think if we move, well, we're allowed to move to the next tile. And we already know that we're having a direction. So we already know we're not none. We're going to say if. Do we even need to say if, or should we just change it? I think, well, let's do an if. If, let's see here. I guess we could check both directions at once, really, right? So we could say if my game player entity dot x does not equal. So let's say also next tile origin. What do I call this? Tile origin. I don't know why that's not filling in. This is next tile chords. Oops. Guess it's not filling in because this is half complete. That's probably the why. So if x is not equal to next tile origin dot x, or access x, right? It's a dictionary. Then go ahead and move it. My game dot player entity dot x equals. Set it equal to this. Also, we can do the same check for y. Entity y is not equal to this y. Let me set it. Yeah, so I think this logic should stop us from getting too close to the wall when we turn. Let's test it out here. Go down. Oops. Nope, we got a bug. Let's see. Okay. This. These must be integers, not string. I returned a tuple, not a dictionary. should probably make this consistent. Like some places I have a dictionary with X, Y, and some places I have a tuple. I should probably do the same everywhere. Okay, there we go. It moved really fast. I guess, yeah, so we don't want to check both directions, actually. Do we? Yeah, we only want to do... We only want to do... honestly, we only want to do the direction that we're not moving. So if we're moving side to side, then we want to check the Y pixel. And I guess we should do it after we move. Or I suppose it doesn't matter if we do it after or before. And then if we're moving up and down, up or down, then we want to do the X pixel to center within the tile row that we're moving. Tile column it would be. Now let's try that. Yeah, there we go. Now we got our speed back to normal. Okay, so it didn't get it quiet. Let's check. Okay. I think it worked. Let me... Oh. Yeah, I think I just saw it right there. It's pretty easy to go too far. Yeah, I saw it again. Okay, that's definitely working. Okay, so now we won't get too close to the wall. It's perfect. So next I want to pick up the dots as we move over them. Yeah, you're right. I was going a full tile. Essentially, by that logic, check in every direction. I was jumping forward each tile, basically. So now let's say when we move onto a tile, if there is a dot on that tile, then we're going to eat it. So we are moving tile coordinates. So let's say we can go mygame dot tile properties, I think. Some of these still are not filling in. Get tile name. The tile name, I guess, would do it, right? I think we should have the tiles named. That one's named wall. This one's named pellet. Can walk is true. Yes, we don't really have another property. We'll just use the name. So I think we say get tile name. This takes an XY, I'm pretty sure. This would be next tile chords. That's a pellet, then we'll make a score. We don't have yet. Score. And we'll plus the score whenever you eat the pellet. Plus equals 1. And of course we need to take the pellet away. Otherwise, you would just count up forever and ever each time you moved. So we'll say my game dot. This is gonna be layers. I think it's gonna be layers, and then well, let's see here. What does get tile name check? Tile property. Tile ID is just using. Oh. Oh, no. Yeah, this does take a okay, this takes coordinates. Get tile. I'm trying to see if this is checking the map or if this is checking the tile grids. Okay, map object layers. Layer 1 for entities is what we want, the foreground layer. You know what we should do actually is let's not do this part yet. Let's just make sure that this is actually going to be getting the right name. Let's put these commented out. Let's say print my game. This, let's print. It'll just spam pellet over and over again if everything's working. Yeah, it totally is. Okay. But we're gonna want to change it in map object layers, layer 1. Data. We're gonna need to make it refresh as well, though. I think we'll need some kind of function to change it in the tile grid. We also need to convert from tile coordinates to index within the list. We have like a get tile index. No, here we're just calculating it. So we could make one though. Get tile def. I'm gonna call this index from chords. Takes tile coordinates. And it's basically this logic. Return. Okay. Now we can use this here. Resolved. And I copy pasted. Unresolved reference. Oh, I guess it would be self. Yeah. Okay. App object, okay. This is app object layers 1 data. There's 1 data. Index from chords. File chords. Equals. But we kind of just need to know the index of empty. Doesn't really matter which empty spot we use. I don't think we could use any of these empty spots. Let's use the last one. This is ID 24. These are 0 based. Okay, so that would update it in. That would update it in the map object. But it's not going to update the screen. But what it should do is make us not spam pellet as many times. Because now it should only do it once per tile. Here, 23. So maybe. So movable to 12. And walk file type. Maybe I should have not done 24. Maybe those are actually 1 based. Does this run once and then we get the error? Yeah. Maybe I No? Same thing. Error 22. So we're not getting... Maybe we just are not keeping a blank tile as a valid one with can walk. Properties. Let's print tile properties. Okay. So yeah, we don't have a blank tile that officially exists. We have blank tiles in our sprite sheet. But I guess because we didn't give them a name and a can walk, they don't count as tiles. So let's do that. Let's take... Well, we would need to edit the tile set. I'm gonna donate to the people who made this. Not done it yet. How do we edit the tile set? Let's see. Edit the tile set. Right click this? Yeah, there it is. Zoom in. So let's say... Honestly, let's put it on all of them. We might as well. And eventually when we fill these in, we'll change them to not be blank, but this way it won't matter which one we use. Add property name, blank. Add property boolean. No, boolean. Can walk through on all of these. We set it to this. We already have this in the background. Technically that would work too. It's alright though, let's use one of our blanks. I'm gonna save this. And I'm gonna save this as JSON. Now we need to move that to the device. Wrong one. Okay, so that's saved here. Write it. Our blanks should be valid tiles. I don't see him still though. blank. We're doing 0. Yeah. I'm gonna delete 0. The device, I'm gonna rename this. Okay, now we have a bunch of blanks. We should probably do 24 instead of 23. It doesn't actually matter, but I do want to keep it as the last tile in Sprite sheet. When we add more, I'll add them before the last one. Okay, so 4 plus 1, 4 plus 1, 4 plus 1. Let's turn off whatever's printing Y setter. Ooh. Okay. That's interesting. Y setter. It is right here. Why did... Oh, I did underscore. Okay, let me clear this. Oh, I guess I don't have an easy way to clear it. That's alright. Well, let me do this. Let me do restart. There we go. Okay, so we got 4 scores, which makes sense because we put the logic as when we're about to move on to a tile. So we don't eat the pellet from the tile we spawned on, and there's 4 left to eat then. And that worked correctly. So we updated our map successfully, I think, our map data. The next thing we need to do is change the actual tile grid. So we could, I guess, load tile grids. We could either refresh the entire thing, which I think is pretty much what this would do, or we just change specific index in the entity tile grid. Camera width, camera height. Yeah. I think. Let's see if it's too slow if we just call load tile grids again. Maybe load tile grids is has an underscore, so technically it's meant to be private. It's also no, okay, yeah, it's on the object. So let's make one def update tile grids. Let me just call the tile grids. This is too slow, then we'll just edit the one index, but this should not be camera lock though. This should be camera width. We need to save this on self so we can use it later. Oops. Okay. I guess we would. Let's say we could do X and Y here as well. Okay. Update tile grids will just refresh all the tile grids that are currently on the camera vision. Probably turn off some of these prints. Okay, yeah, that's way too slow. It is working though, but it's way too slow. So we want to just modify the one index. So we're gonna go Unity tile grid. Technically this has an underscore. It's kind of meant to be private. Why don't we make a my game change Unity tile. Change Unity tile. This takes a tile coordinates, and it takes a new tile index. And it will do both of these things. It will set this. Your tile index. And it will also update the tile grid. Self.entity tile grid. Tile chords. And is it the same as new tile index? Need to add one, subtract one. Okay, so let's say if we had this function, then we would not need this. Instead, we would just say my game change entity tile at next tile chords 224. Yeah, that's much better, and it looks like it's working. As we move through the pellets, we are chomping them down. Oh, that bottom one we still didn't get. Interesting. So something about the bottom corner. Oh, because it doesn't have a pellet as the player. Why does it get a pellet underneath it then? And I guess, do we want to make... We want to make a third layer for the player, and then technically the player will be allowed, there will be an entity underneath the player when it spawns. Yeah, I almost think that's what I want to do. Foreground, background, player. So in the foreground, this is actually pellet. In the player, then this is Pacman. So when the Pacman's not there, there's a pellet underneath it. So I'm gonna save this. I'm gonna export this. Save it as the right one this time, 0. So I have both of these open. And we need to change the logic for finding the player. Okay. Tiles 2. X. Tile index inside entity tiles. So we need to check we need to check entity tiles here instead of, well, no, we need to check player tiles instead of entity tiles. Get tile property. And we ID. So we don't really have, we always want to place the entity. This really shouldn't be an else anymore. I'm gonna comment this out for just a second. This is gonna come back. So we always place the non-player entity, and then we check if the player entity exists, which we can do by saying player index is player tiles index. Probably change the name of some of this stuff. Okay. This is going to get the index of the tile at this location in the player tiles layer, which is now our third layer. If that tile index is player, then we set the player's location. Else we don't do anything. We don't care if it's not player. Those are the only possibilities, is player and don't care. Ooh. No, it didn't find the player. Let's make sure the layer with index 2. Yeah. Is actually the player layer, which it is. Does it have a player sprite? Uh-oh, those look like all zeros to me. Oh, there it is. Okay. Print this. I assume this takes player index. So it seems like that should do what I'm expecting. So let's check out what gets printed. Okay, we should turn some of these prints off. This. Player tiles definitely does have player index in it. That should be fine. Oh, these are getting duplicated now because it prints from inside building list also. We have our player. Why are we not finding it, actually, when we are inside of here? Put one of these back. So on X is 1, 2, no, 0, 1, 2. Y is 0, 1, 2, 3, 4, 5, 6. On 2, 6, we should have a 1, which is our player. 2, 6, we do have a 1, which is our player. Should we not be minus 1ing? Tile property. We print the tile properties dict, so 0 is player. Should be getting 1 minus 1 is 0. Did we ever print found player? Print it on 2.6. We don't. We shouldn't be passing two things here, should we? I think our parenthesis got messed up. Oh, no? Tile ID, property name. Property. So player is a Boolean, I think, right? Yeah, player is a Boolean. Wait a minute, where did... Okay, this is the local copy that's not on the Pico. It's not what I want. This is the copy that's on the Pico. Ooh, minimize this. I'll close it too. I guess it's where the map is saving. I guess I could change that, but... Okay. So get tile property of 0 should be returning true for player, but it's just not. Print player property game get tile property so 0. Does tile index 0 show player property true? It does. So why does it not work then? Hey Johnny, how's it going? On player tile index. This needs to be player tile index. Player tile index, duh. Yep, that's gonna do it, I think. Okay, I'm gonna see if I can fix the focus a little bit. Okay. What's the error? The error -1. I think we should just turn none. It's negative. Get tile property. If tile ID greater than equal to 0, then do this. Otherwise, we'll return none. There we go. Okay, player's in the right spot. Go up. Can go over. Go down. Can eat the corner one now. Here we go. Okay. What do we want to do next? We could add the ghost. Or we could add big pellets. Right now we don't have big pellets. Like in the game they have big pellets, you eat the big pellet and it turns the ghosts to be susceptible to being eaten. So I guess, I mean, the big pellets don't really do anything until we have ghosts. So I guess we should probably work on ghosts next. Bought an apartment. Needs Wi-Fi and a laptop, external screen. I gotcha. Lots of hookup going on today there. Setting stuff up. 2 hours in the store, dang. Yeah, I guess I'll work on the ghost next. So should the ghost... In the game, the ghosts spawn in a little pin in the middle. They kind of get let out over time. I think I should work on just the core logic of the ghost moving around and stuff, though. Because that's going to require fair amount of stuff. Like, I don't currently have an entity tile grid, but this is holding the pellets. An entity tile grid is wanting to be snapped to the tile grid. The ghost is going to behave more like the player does. So, honestly, the name entity tile grid is not the best name. Because really this is holding the pellets and the walls. Which I guess you could count those as entities, kind of, but when I think of entities, I think of more of like the player and the ghosts, which will end up actually having the player already does have their own sprite and their own tile grid. The ghosts will as well. So I almost want to change this to like map tile grid instead of entity tile grid. Especially because my player is an object that's called entity. Yeah. So I'll make some more of these entity objects that will represent the ghosts, and those will end up with their own tile grid. They're not going to go on the entity tile grid. So yeah, I think, why don't we change this from entity tile grid to map tile grid. Yeah. We'll refactor that. This should now be called map tile. Change map tile. Factor. This should be map tiles. Self.empty map tile. Map tile. Okay, I got all of them. Now we have map tile grid, map tiles, and all of that terminology instead of entity, which I think makes a lot more sense. So I think we would, I called this player layer, but truthfully this is going to be the entity layer. So really our three layers are the background layer, the map layer, and the entity layer. And I don't think it matters what I name this. I don't think any of the code is actually using this. But I will do that, and I will also do map this. and I will be right back. I gotta run to the restroom and then I'll come back. So we'll be back in just one moment. All right, now we can add a ghost onto the entity layer. Start with just one, but we'll try to build the logic in such a way that it will eventually be able to handle multiples. Oh, I'm on the map layer. Okay, let me put this back to pellet. Let me go to entity layer, ghost. There we go, okay. So I'm gonna save this. I'm gonna export it as JSON. Okay. Yes. Copy. Paste. All right. Okay. So what we will do is same spot where we checked for the player. We'll also check for ghost. So here we'll say elif self dot get tile property player layer index -1 is ghost, but ghost is not a boolean. Ghost is the name, whereas player is a boolean. So what if we do get tile name? This one takes coordinates. X and Y. We should probably have like, maybe we should have one set of functions like getTileProperty and getTileName that take the ID, and one set of functions that take the coordinates. So right now I'm mix and matched. Like getTileProperty takes an index. It maps the index of that tile in the list of all the tiles, but getTileName takes coordinates, XY coordinates, that's checking the map, but that's going to get pellet actually. Okay, so yeah, actually I think what I want to do is not use name. This is going to be property also, and we'll make a new property called ghost. And so here we'll need to, I'm going to put pass for now to get it to not underline, but here we'll need to create a ghost entity object, set its position to the XY we found. What are these XYs? Load tile grids. So let's make this ghost. Set the tile set, go to ghost. Let's make a new property ghost. Turn it on. Off for everything else. We're gonna save this. Go back to here, we're gonna export. Copy, update, paste. Yeah. So now we have a new property called ghost. So if property in the player index is ghost, then self dot, I'm gonna say enemies dot append. We're gonna say that this will be a list. Self dot enemies is a list. Basically gonna get one of these added to it. Default tile. Default tile is this. Should be the ghost. That should be the ghost. Enemy equals a new enemy. I'm gonna put this into a variable first. So we'll create enemies whenever it finds them. We need to add them to the group though. I think that would be at the end of this for enemy. in enemies self.append enemy. Yeah. Right now we should only have the one, but if we had multiples, this would still work. Let's see, does that crash? Or do we get a ghost? Crash. Crash. Layer must be group or tile grid. Maybe I thought entity extended that, but I guess not. Go to it. Okay, I can dot tile grid is what I want. Here. This restarts a bunch of times. Okay. So we got a ghost, but it's not in the right spot. Why would it not be in the right spot? Sets the XY of the tile grid, which is what we want. I would think that would be what we want, right? I guess we could do the plus. I think right now these would be 0. These are basically the camera offset. But right now, our camera's at 0, 0, so these would actually still be 0, I'm pretty sure. But underscore X and underscore Y, these should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 2. This should say enemy lock 13, 2. I think. I don't actually know where that. Okay. No, this is different. We should turn off some more of these things now. Player layer index, let's turn that off. Enemy lock 13, 2. Oh. This needs to be multiplied by the tile width. Yeah, so our ghost is not, I assumed it was at 0, 0, which would have been the default, but it's not at 0, 0. It's at 13, 2 in pixels, not in tiles. So what if we had a a setter? You would need Tile width. Do we want properties that deal with tiles inside of here, or do we want to multiply it out here? I guess let's multiply it out here. Okay. And now the problem is we're printing the values, but not setting them. Honestly, I should cut this, put it here, cut this, put it here, and then just access them here. This. Okay. This should put, oh no, we have red. Oh, we don't need this pass still. Oh, what I lost my, happened? We don't need pass. There we go. I formatted when I was missing a parenthesis and it messed something up. Something like that, maybe. These get multiplied, get set into the XY, we print out the XY. So do we have a ghost in the right spot now? We do. Perfect. So now, if the player runs into the ghost, then they lose. Or lose a life, at least. I guess we could have multiple lives eventually. So where do we want that logic? I think we want that back up here. Where do we check for pellet? How do we want to do this? Is get tile name is not gonna check for enemies. We basically need collision detection between the player and ghost. So why don't we say def is colliding. You pass it another entity, and then we do the check in here. If so, we return, come on, false. We're not colliding if self dot okay, what's the logic? It's Rx is Rx is less than file width different? No. Rx plus our width. We check if two rectangles intersect. Seems like a geometry problem, right? Check if rectangles intersect. What is this formatting? Is there a prettier formatted one? We don't have rotations to worry about. Separating axis test. This looks like it's checking every point. It's also dealing with rotated things. Separating axis test. Separating axis test. Let's get us. Okay, sounds promising. You're able to draw a line to separate two polygons and they don't collide. Let's assume for now that the polygons we refer to are squares. Box one on the left, box one on the right. Easy to see. Squares are horizontally separated. A straightforward approach to determine this in code is to calculate horizontal distance between the two squares. Then subtract the half widths. Box one and box two. This we don't have to worry about. We don't have rotations. Okay. Okay. So we'll just see if this works. If we say length is self.x minus other entity.x, half width self width over 2. Do we want to do integer math? Half width other. Okay. Gap between equals length minus half width self minus half width other. If gap between greater than 0. Trace, I guess, must be print. Big gap. So if there's a big gap, they're not colliding. So this would be return false, I guess. We could, maybe we'll change the logic around after this, but elif gap between equals 0. Boxes are touching each other. Return true. Elif gap between less than 0. Boxes are penetrating. Return false. No, return true. Is that it? Boy, I mean, I get it with this picture, but shouldn't we have to check Y? Nothing ever checks Y. Right, because yeah, do we need to do this for Y also? This horizontally separated. I don't care about rotation. I feel like the part we have so far only tells us if they're not touching horizontally. But if they were touching vertically, we would not know about it yet. So if we have our two boxes, well, let's not do an angled one. We had a box here and a box here. Well, we can duplicate. Okay. This is what we figured out, is that we're not touching this way, but if we had a box here and a box here, this would return false. Wouldn't it? The x, the length would end up being 0. The x is the same. Half the width is 7.5 in this case. 7.5, 7.5. Gap between 0 minus 7.5 minus 7.5 is -15. So this says that they are touching, but it's because they're aligned horizontally. Well, aligned vertically, or I guess it depends how you think about it. So we need to do the same logic for y in half height. And then we will know for sure if they're colliding, I think, right? Okay, so the gap between is 0, just pass. If it's above 0, then just pass. Really, honestly, I'm gonna call them XY instead of horizontal vertical. Right now, what we're doing is colliding X. True. Oh, X. True. We need the exact same logic with Y and half height. Length. Call this length Y. Call this length X. This is our Y minus their Y. Half height. 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 Okay, right here, length Y, colliding Y, colliding Y. Then we return if both collidings are true. Turn colliding X and colliding Y. Yeah. Duplicated code fragment. Not really though, right? I mean, it's width instead of height, and y instead of x. I mean, that's just not duplicated at all. Those are different. I don't know why it thinks it's duplicated. Okay, so we should have logic now that one entity should be able to tell if it's colliding with another entity. So when the player moves, let's say if my game.player entity is colliding, we need a loop actually for enemy in my game enemies if my game player is colliding enemy print player colliding with ghost. It'll just spam it if it's true. That's fine for now. Let's save this. Okay. So if we go over to the ghost, will it start printing? Does. Perfect. Oh. Doesn't stop though. It still thinks we're colliding with the ghost. Should have we done an or instead of an and? It seems like we are colliding with the row of the ghost. Not the column of the ghost, though. Sorry. Let's see. Could scoot it back some, maybe. Why? Hmm. Colliding X. Colliding Y. Okay. We have colliding X is true. It really shouldn't be. go my game player x, my game player y. Indicate this for enemy. Hey, thanks for the follow, Luzaka, appreciate it. Oh, you're helping me out in the Twitch chat here as well. Let me catch up. Calculate the distance between their middles. Absolute value of x minus other entity x. Length y may be negative. I see. We want the distance, not the. Hey, thanks for the help there as well. Appreciate that. I didn't see it until now, but do appreciate that for sure. So we do need to take absolute value of the distance. Back inside of here. When we're subtracting these, we actually want absolute value. And I guess we probably want the same thing here, I would think. Yeah. Okay. There we go. Now we're getting false, false. We go up to here. We're getting false, true, which makes sense because we're in line with it. We're not actually colliding fully. If we go over here, we'll get true, false. We do. That's looking good. And if we go all the way up on it, now we'll start getting actually collide. Perfect. Back here, when we had true, false, we're not colliding. As soon as we start getting true, true, then we are colliding. Hey, thanks for the help on that again. Appreciate the pointer there. Okay, so that's perfect. We're getting the collisions now. So, what do we want to do? I guess really I don't have lives or anything yet. I guess what we could do for now is just restart the level with all the pellets intact and all the enemies back where they're supposed to be. How do we do that? Let's see. We would want to basically redo a bunch of the logic from the constructor. And we need to reread the map file too, because we changed it by setting the pellets to blank. So I almost wonder if we should just make a new tiled map game. It's probably more efficient to take a bunch of the logic out of the init function into its own function and then call that. Then we could reuse some of the objects, but we could also just make a new instance. Yeah, let's just start with making a new instance and see what that ends up doing to us. If that's too slow or run out of RAM or something, we'll optimize further. So let's say when they're colliding, we're gonna reset everything, basically. We could turn these prints off also. Let's say main group remove my game, and then my game equals new my game, new child game map. Eventually we'll keep track of which level we're on too, and we'll load the correct JSON for our level, but right now we pretty much just have one level, so doesn't matter too much. Game map, okay, reload. All this stuff is the same. We could, doesn't really matter the order we do this, I don't think, but I'll move the print up here. And then we'll do, we removed it from the group, we made a new game, so we'll go add it back to the group. Whoops, main group append the my game, which is now a new instance. That should reset everything when we collide with the ghost. Let's see, let me catch up here on the Twitch chat also. Store the width and height and default player and enemy's position in the file. So the JSON file technically has that information. With height and default. Yeah, I'm not sure if I understand fully what you mean, but the I can say this map.json technically has the player location, the enemy location, and the width height as well. So the locations, I mean, it doesn't have them directly, but it can look them up out of these lists. So it would find entities, which are the ghosts and the player. It would find them in this layer of tiles. It could then use their position in this, plus knowing the tile width, which it has somewhere. This is all tile stuff here. This is just a list of tiles. Tile width it has, and tile height. So we could use those combined with the index in here to know where the players and the entities are at. And then the width and height would be equal to the tile width and height. It does know that stuff. I guess it would be nice if we had... Maybe it'd be nice if we could keep the same tiled game map object, but then add like a load JSON function. And so here we'd be not making a new object, but instead just calling like load JSON, like load map. That might be a good way to do the API eventually. I'm gonna see what this one does though. Let's shrink here. Go here in case we crash. Wow. Let me turn that off. I should use, there's a logging library I did some PRs on recently. Didn't know it existed. I should use that, because then I could set levels, and I wouldn't just have to go back and turn on and off all these prints. I could just do like debug level or whatever. Here it is. That would be a good idea. Should do that. Okay. Munching, munching, munching. There we go. And it reset. Perfect. Yeah, nope, wasn't fast enough. Let me see if I can get it. Nope. Is there not enough room to get by there? Seems like maybe there's not enough room. I'm catching on the edge of the wall there. Thought that would have snapped me over though, truthfully. Yeah, so it seems like there maybe is not actually technically enough room. Once I get far enough to the right to get past the wall, then I'm too far to the right and I touch the ghost. Yeah, it doesn't look like I can get through there. Let's try it this way. Yeah. Are we off by one somewhere? Or maybe our collision logic had like touching versus actually intersecting. Maybe we don't, maybe we're fine with touching, but not intersecting. Maybe it should be like this. Oh. There we go. Okay, now there's enough room. Perfect. Okay. And obviously the enemy doesn't move yet, but the other thing we need to do is check for when the level is completed. When all the pellets have been eaten, then the level is completed. How do we want to do that? I could do it inside of here, and that would be pretty easy while it's loading the tile grids, but that's not very generic, right? This is supposed to just be a generic game helper library. We probably shouldn't put the actual pie chart chomper logic inside of it. Yeah, I don't know the right way to decouple that right now. Like, somehow we want to be checking inside CodePy if the map is complete, which in our case that means if all the pellets have been eaten. I think we'd rather not. I mean, we could always just iterate over every tile. But I don't think like that will take a while. I think I don't think that's the way we want to do it. If we could store the number of pellets that there are after we load the map, and then subtract one from it each time we eat one, whenever there are 0 left, then we know that we've got them all. That seems more efficient, because we don't have to check every tile, every game tick. But I can't think of a good way to decouple that from the game helper object. How would we do that? Okay, what if we provided a function that said, like, get count of tiles of a tile type? I guess we already have some logic in here that shouldn't be. Like, this should probably be I guess this should probably be enemy instead of ghost, since that's more generic. We do already kind of have our logic getting tangled up in the game helper. Could keep a dictionary of counts? We could modify this object once it's in memory, like as we load, we could be adding a count here, and when it finds the first one, it sets it to 1, and when it finds another one, it increments it. So then at the end, we would have a full list of all the different tiles and how many exist of each. So then we could go back and say how many of the pellets are there specifically. Kind of like that idea. So this would not actually change in the file, though. This would change just in memory. If we said self.map object tile sets tiles oh, this actually has 3 copies of the same. Oh, no, it doesn't. No, it doesn't. These are each tile. Yeah, these are each tile. Okay. So map object, tile sets, tiles, tile sets, tiles, tile index, -1. If count not in. In here, if it does not have a count, then set the count to 1. Also, if it does have a count, then increment. Oh, count. Plus equals 1. Okay. Now we'd be building a count of all of those. So after we load the map, we should be able to just say like, I'm gonna turn off some of these. This one we could delete. So let's go print my game map object file sets files. This will print an object that includes the counts. Everything's working. Oh, 191. List indexes must be integer, not string. Does this need to be keys? That makes a difference though. Oh. So that's this level, this should be map object. Look inside tile sets. Tile sets is a list. We only have one in it, but it's technically a list. Okay. Okay, so we would say tile sets 0 tiles. Okay, there we go. And we'll need it out here too. Okay, so we want to find the pellet. Let me format this. That's not very useful, is it? Why is that such a bad formatting? Alright, well, it doesn't matter that much. Pellet, count 42. So let's say files. In terms of the actual index, this is 0, 1, 2, 3, 4. 4. Count. Should be the number of pellets. Indeed, 42. Okay. So let's say remaining pellets. I don't know how to spell pellets. Equals this. 2 L's and 1 T, or 1 L and 2 T's. Two L's and 1 T, thank you. L's. Yeah, I'm terrible at words with doubles of one letter and singles of another letter. I'm always mixing up which one should get doubles and which one should get singles. Okay, we don't need this space. So now we could just say whenever we eat a pellet, then -1 here. Remaining pellets minus equals 1. And if remaining pellets equals 0, print you win. So if we eat all the pellets, should start spamming that we won. Never spell pallet right. Yep. If I had to deal with pallets, I'd probably have that same problem. Okay. Let's see if I can do this without running into the ghost. Go around this way. Ooh, that was close. Oh, there's a pellet underneath the ghost. I need the ghost to move. Yeah. Really, we need this logic. We need all this same logic for ghost. For all the ghosts. In this case, we just got one, but... I don't think we should ever really end up with the ghosts needing to snap to. Guess it depends on the logic the ghost uses to move. I think to keep it simple, to start with, the logic for the ghost movement will be just go in a direction and then keep going until you run into a wall and then change directions. Yeah, so really we need to do all of this stuff. We need to get the next pixel for the enemy, the next tile chords for the enemy, check if it's movable. We don't need these parts because the enemy can't pick up the pellets and the enemies will just pass through other enemies. They won't collide with each other. But then we will need all of this still. Pretty much want for enemy in my game enemies do the same stuff. I'll start working on this. I'm gonna wrap it up here fairly soon, but see if we can knock this out real quick, or if we run into trouble. Speed will still respect the tick speed. That makes sense. Go in here. Next pixel lock. This is now gonna be enemy. Enemy. Well, yeah, but we also need this. If enemy direction so if it's actually facing a direction, that's the other thing we'll need to do, is set the direction on it. If it's actually facing in a direction, find the next pixel, next tile chords. If is movable, then have this logic. Note there so we know what this is for. This would be enemy.direction. There we go. And this would be enemy.x. And yeah, I don't think we need the snapping. Oh, this is just enemy.x, not direction. Enemy.y, don't need this. Enemy.y, don't need this. Okay. And then we'll just say else up here, which is else it was not movable, the tile that's in front of us. Then let's just we have like a direction list or anything? No. Each of these do have numbers though, with none being 4. Probably should have been none is 0, huh? Oh well. Up, right, left, down. Yeah, these are not in cardinal direction order or anything. So let's just make the if statement and say if the direction is currently right, then we're going to change it to enemy.direction equals direction. Let's say we're going to turn left. So we would go from right to up. We would go from left to down. We would go from up to left. We would go from down to right. Yeah. We're not allowed to move to that tile, then we're going to change directions by basically turning left 90 degrees. And then the next iteration through, we would check a different pixel. So like then if we were stuck in the corner, we'd be checking a different pixel and turning again if we were in a corner. I think that logic will work. Oh, we need to give the ghost the first direction though. Let's set him going left when we first start out. I think I'll just hard code that somewhere. Maybe we'll just do it here before the main loop starts. My game, enemies, 0. We only have 1 right now, so that's fine. Direction equals direction left. So it'll be moving left when the game first starts. It should hit this wall, turn and go down. Hit this wall, turn and go over, hit this wall, turn and go up. So we'll basically be going around the outside on this map. But of course it would depend on what the walls were. Okay, let's give it a try. Alright, ghost is moving. Oh, it turned around though. Well, this will still let us test if we win or not. That was the first thing we added. Although I guess this row is going to be kind of tough, isn't it? Here's what we'll do is this. Go that way, dinner back around. There we go. So now, is it spamming that we win? No. Oh, yes. Well, it's not spamming, but it did print. Perfect. Okay. So, yeah, we would load the next map at this point, basically. Because I think this game will be level-based. You clear one level, and then it will move you to the next level. Yeah. Party time. We are getting pretty close to having, like, a pretty legitimate pie chart chomper game here. Let's see, why does it go back and forth? Let me see if I can figure that out, and then I'll probably wrap it up for the day. So, while we're moving left, we get all the way to here. Our next tile coordinates and everything would be on the wall. We would check if we're allowed to move on the wall. We're not, so it would be false. It would come down to else. Thank you. Got my ghost evasion. I was thinking a thing that might be kind of cool to add is like you drop a I don't know what they're called, but like the thing that the Ghostbusters use, they drop a box and it like sucks ghosts into it, some kind of like ghost vacuum box. I think it'd be cool if you could like press maybe A or B and it drops that box, and then whenever the ghost runs over it, maybe it'll get eaten and stay inside the box for a while and not move or something. There's nothing like that in the original game, I don't think, but I was trying to think of ways that like stuff we could add on to it to make it more fun. And I think that would be kind of cool if you had a certain number of those boxes. I should find out the name for it. And you drop it, and the goal is like to drop it where the ghost is gonna walk on in a little bit. So let's see, if the direction was left, and we should be changing it to down. So does it loop around again before it has a chance to move? This is for enemy and enemies, so we should only hit the single ghost once in this loop. Direction starts out as left. Pixel current direction, which right now is left. Tile coordinates. Print each time? Yeah, that's a good idea. Print. Turning to face up. We'll just do it this way on each of them. Whoops. Down. Left. Right. Okay, it went like all of them. Let me see that again. Oh, I don't have else ifs. I don't have else ifs. Yeah, this is my problem. These need to be else if, right? Otherwise, this one has the opportunity to trip after this one has already happened. Yeah. So then it's just going through the full list. If I had gotten lucky on the order of these, then it would still seem like it worked. But this will make it actually work, I think. Oh, I should move. Yeah. Oh boy. Got us a chase here. Let's get out of the way. Now let's go this way. There we go. You win. Park right here since it's safe. Since my game doesn't reset yet. Alright, I think I'm gonna call it there. Let me take my code and put it in the repo. I started a repo for this when I first started working on it, so we'll update it here. That way, in case anything happens to the Pico, we still have it. I changed some inside Tilemap game as well, so I'll grab the copy of that also. And I also changed entity actually, so I'll grab that as well. Guess maybe I never put this in a repo. Otherwise they would be colorful. So maybe I'll make a repo real quick and then wrap up after I do that. So let's grab entity also. Paste. Overwrite. There we go. Okay. Let's go get init. Repository. Yeah, I'll do this real quick and then wrap it up. I am running. That's a good question. Not the release of a dirty build. I must have made a build for some reason. I don't know why. I don't know why I would have made a build though, truthfully. I should get the release one though, truthfully. Let me do that. Remember what I was testing, why I would have made a build. Must have been something though. Oh, so I probably do have that same issue. Because I probably made this. I don't remember what the timing on the release was, but I may have made this after the release. Is there a fix for that? Like if I build from main, is it resolved or is it still an issue in there? Oh, you know what? I think it's fixed in the 7.0 release. Oh, okay. So I'll install this. I guess One problem is, though, I don't have a reset button wired up, so it's not super easy for me to get to bootloader mode. Can you get to the bootloader mode from the REPL? Isn't there like a supervisor restart and then like restart in bootloader? Or does that go to the... Maybe that goes to the ROM bootloader on this device? I don't know. I got my breadboard here with the button actually from the last time I updated it, so maybe I'll wait and do that later. I can unplug the screen and plug in the button. Breadboard. Let me go ahead and make a repo though. Okay. Chapter. Python pie chart chopper. Yeah, we'll just don't even bother with the description. People can figure out what it is. Public we want, ignore. I'll just make my own ignore. Yeah, I'll do a license. Main is the default branch. Let's see if I can do this correctly. So I wanna, as an update, if anybody was watching the stream a few weeks ago, I thought I changed some setting to make this do main by default, but it appears that did not take effect properly. So I do still end up with master. So I do want check out main. Now we want to go get remote, add foamyguy. This? Nope. This? Get fetch foamyguy. Can I pull? Can't update. And has no tracked branch. And has no tracked branch. So what if I said git checkout initial working branch? Initial working branch. Then checked out remote main, which has a license in it. I'm on main, but I still have all my files. My initial working seems to be gone, but that's all right. Should be able to add and .get ignore, yeah, .idea star. Everything else can be checked in for now. Okay, so let's make sure we didn't get any idea files. Doesn't look like it, which is good. Okay. Initial commit. main. All right, we got it on the first try. We made an extra branch that didn't end up needing to exist, but we didn't lose any code. We didn't have any weird merge problems. Okay. Hey, thanks. Yeah, I appreciate the comment on the name there. I thought it was a cute way to make it a little different than the regular game Pacman. I'll probably come back through and change. I should change like the sprite sheets and the maps and all that. I should get rid of like just not use Pacman at all. So I don't have the rights really to use the name, but I think my game is enough of my own implementation. Hopefully I'm not skirting into any trouble. I may end up changing it up too. I was playing around with some other ideas. I think it'd be cool maybe if the chomper could change colors, and then maybe like you're allowed to eat the same color ghost that you are, or vice versa. Maybe you eat different colors or something. So I may add that wrinkle into it as well, which I don't think was part of the original game, but would make it a little more interesting. But all right, so we got our repo up. Oh, one thing I noticed actually while I was doing that is that we need to check collision for the enemy. So right now we only check collision when the player is moving. So basically we're only checking if the player moves into a ghost. We're not checking if the ghost moves into the player, which is why right now the ghost is going around and around and hitting our player, but not causing a reset. So that's something that we need to do next time. I'll make a to-do. So check collisions when enemy is moving. See if they ran into the player. Yeah, so we'll need to do that. Probably spelled collisions wrong. Yeah, see? I got the single L double S. I did it backwards. I don't know why. Just cannot get those right for some reason. Add to do. Check that in so I have it for next time. All right. Thanks for hanging out, folks. Dexter, Johnny, and Skur. If Skur was here, I don't remember for sure if that was before we started or what, but thank you to all the folks that hung out. Thank you in the Twitch chat if you're still there. Luz Zaku for helping me out with that tip on the absolute value and for following. And I will catch you all next week. Should be streaming at the normal time, which is 10 a.m. on Saturdays. So I started about 3 hours ago, and I start at the same time every week. So, 3 hours ago in your time zone, whatever that is, on Saturdays, that's the time I normally stream. So you can catch me next time if you're interested. Thank you to everyone, and I will see you then.